он нам поставил опоздание, то есть -1 балл. Вот, а также, когда сделали домашнее задание по английскому языку, он каждую работу проверяет на плагиат. И там,
да, я знаю.
типа, одно предложение взято из Википедии, все.
Не-не-не, это ты, как бы, если ты ссылку не поставил, то, конечно.
Да.
Но надо ссылки просто делать.
Надо ссылки сделать.
Конечно, ссылки не плагиат, это не является плагиатом.
А Википедия разве вообще считается плагиатом?
В идее, да.
Теперь сами проверяем сейчас свою работу на плагиат. Потом справляем дальше.
Пока. Здоров.
Можно?
Ну, почему нет?
Где все?
Не знаю. Ой, сравним радость.
Все, 25 лет. Да. Могилку, так сказать.
Только самый рассвет.
Да. Выхода нет, скоро рассвет. Вы поверни, полетели.
Нет, там просто много было.
Я давно не... Я тебе говорю, что
Как полагаю, за них.
Когда холодно, думаешь лучше.
Мы наоборот пододеваемся.
Ну смотри, уже вот тоже не хочется работать. Значит, это... Такой вопрос, это вы слишком умные или первая группа тупые, или просто я тупой, и вы на самом деле ничего не понимаете? Почему они не успевают даже половину пары где-то провести, а я их за 10 минут раньше отпускаю? Есть предположение?
Только весьма печальные предположения, только весьма
То,
печальные
что
предположения.
все думают, что они понимают, а на самом деле нет, и подобными вещами вас вынесет?
Да нет, вроде все понятно.
Обычно первая группа это олимпутники, чтобы вы понимали. Ну там типа самые монстры ходят обычно туда.
Ну, видимо, они слишком глубоко зашли в математику, все.
Ага, я не знаю, где они там глубоко зашли, они не понимают, что такое детерминант сегодня. Вот, ладно.
Нет, на самом
Мы
деле
потратили
детерминант.
целый день, чтобы понять, что это
Ну сейчас мы разберем.
и разобраться со всеми задачами.
Ой, да там
Особенно там последняя, это гроб.
какая?
Это про сквер трипл продукты, и там последняя задачка, где еще градусы. Ну, короче, нужно было менять базис, да.
Ну, на самом деле, эта домашка, как бы, она... Объясню, в чем фича. У вас должна была смена базиса на этой паре, но вам не успели ее прочитать. А задачку я оставил. Потому что она относится и к тому, и к другому. Так что, если я решил, то ты пожина. Даже вот сильно все. Что это у тебя за знак секты?
Это у меня WorldSkills.
Раскрыл? О, прикольно. Клево, мне нравится.
Самое интересное, что ко мне так китаец на чемпионате подбежал, я смотрел,
Подкатил?
да, серьезно, он мне такой значок сам налепил и убежал. Ни слов, ничего, просто налепил.
Говорите, Долохов. Ждем еще минутку и начинаем наш цирк.
понимаю, вы вообще не читаете комментарии.
А что там пишут?
Я уже не помню, что там писали на прошлой неделе.
У них есть PSS. Я же сказал, что у меня, во-первых, телефон где? Вон там. Соответственно, я не могу физически смотреть, что там пишут. Телеграм, если я включу, то как бы, ну это такое себе решение. Вот, а стримчанские, ну типа, пусть пишут.
А вот
А у Римпара мы не пользуемся телефоном, поэтому вы не можете технически это увидеть, так что вот и все. Что говоришь?
Ну, а вы как attendance ставите?
Я attendance, кстати, это провал третий раз, я хотел распечатать, чтобы вы поставили attendance за все 3 посещения. Ну, короче, я вас спрашиваю, шит, вы там сами поставите. Я плевать на этот attendance, я это говорил. Но мы играем в цирк, поэтому, соответственно, я проводил, типа, вы все уходите. Я на всех хотел поставить, чтобы вы все пришли 3 раза, но мне сказали а-та-та, поэтому вы сами запомните, что вы все пришли, и все, и моя совесть будет чиста. Вот. Ну, а эти приходят на онлайн, я типа, они там плюсик в чат ставят, я его сохраняю и никуда не вставляю. Ну чё? So let's start our class. Today we have 3 topics. It's intro to matrices, determinant, and scalar triple product. But I'd like to start because one student asked me to put it in my slides that I am fat and stupid. I put it and you may see me there. Okay. Nice. You may see the slide which you asked. Okay. Now let's go to the real classes. Real talk, you know? Okay. So, obvious objections, we need to get what is it, how we need to use it in real life applications, and how to find some precise classes. Let's start from matrices. So, what are the metrics? Actually, it's a great film.
The Matrix, 3 films about a group of idiots who don't value happiness.
What? No, that's not it at all.
A bunch of idiots can't accept a good thing when they see it.
No, it is not.
Oh, okay, Bob, so you do it.
Oh, I will.
Go then.
The Matrix, a forced trilogy about humanity's struggle for freedom against our robot overlords. What if, in the future, your gateway PC didn't plug into your wall, but into your brain?
Our hero is actual human vampire Keanu Reeves, who plays the cubicle rid in Neo, which is an anagram for what?
While night shift hacking the late 1990s interweb, Neo discovers the mysterious nature of the Matrix.
It turns out these shiny metal bastards are milking mankind for every drop of precious energy they can get.
Reality as you knew it is a lie, and college dorm room discussions will never be the same. A group of rebels with sick AOL chat handles gives Neo a choice. Take the red pill and join La Resistance, or take the blue pill and rejoin all the sheeple.
The choice is obvious. Blue pill.
What? You take the blue pill?
I mean, maybe I'd take the red pill, stay there for a few days, learn karate, stock trading, tax codes, things like that, then double back, take the blue pill, come back to the Matrix, but with like a kick-ass karate outfit and a big savings at the end of the fiscal year.
Whoa. You can't just double back and come back after you take the red pill.
Cypher doubles back.
Cypher is a traitor and a murderer. Even if you could double back, you'd be damning the human race and spitting in the face of free will. Just for what? Itemized deductions and sweet stock tips?
Yes.
Max, this would mean letting machines use your brain as a battery against your will.
Look, the other option is hanging out in a big cave dancing to rave music with sweaty buzzcut people.
You have no free will.
But I have a lot of write-offs.
God, you're like the kind of person who doesn't care about the NSA spying on you because you don't have anything to hide.
I don't have anything to hide. And I'd rather not be mutilated by giant flying machine squids or get my head punched off by Hugo Weaving.
Oh, right, Hugo Weaving. In a way, he's the real hero of the film. He's got the best arc. A simple computer program who picks himself up by his bootstraps and wages war on humanity and machines, all because he hates how people smell.
We do smell really bad, though.
Yeah, humans are mad gross.
That one's on us.
We should all be destroyed.
Speaking about things that should be destroyed, let's get into Matrix 2 and 3.
Man, do we have to?
Well, the Oracle does stuff, right? And Trinity dies like 4 times. The KFC guy is there watching like a crazy amount of TVs all at once.
Yeah, there's that dumb Dragon Ball Z fight scene.
Then, I mean, I think everything works out, right?
I mean, yeah, we're all fine.
Everything works out. TLDW, 1 was a good place to stop.
So, it's a great film, not buttons not only. What does it mean, metrics? Actually, there are 2 ways. Of course, one of these is representation of your values. Actually, you can think, in future, you will think in terms of system of linear equations. So, you can represent every your matrix from your class, I mean when you study at school, as a matrix, most of it, if it's of course linear. If it's not linear, it's not so easy. What else? I divided it into big groups of our operations. It's between two matrices or more matrices and with one matrix. It's summation, multiplication, order is important. You need to get it, no division. And I'll explain why do we need inverse matrix later. And with one matrix, multiplication, scalar, transpose, inverse matrix, trace, and determinant. So we start from this one and have to go to this. About multiplication. Actually, I explained in the previous class. Who didn't get how to do it? Because in previous group, some of them didn't get. So, okay, again. We have, in this case, 1, 2, 1, 2. So, because of dimension, it's 2 by 3, 3 to 1, or 3 by 2. We can do like this, and it will be 2 by 2. So, and we just go boom, 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 it will be this, boom, 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 it will be there. Boom, boom. Is really so it's how can we take it? About transpose. I put there how can you use it in coding. Actually, I think most of you did it because you have main diagonal, so secondary diagonal, and probably you did some task on informatics about it. It seems so. Why do we need transpose actually? There are some fancy words about it, but roughly speaking, there are two ways. First of all, dot products looks not so nice even if you're coding, it's not so nice. So you can represent, for instance, when you go A cross product or dot product B, as you remember in cross product we can also make a multiplication using skew-symmetric matrix 3 by 3 and 3 by 1. It will be 3 by 1. They're the same. We can write A transpose B, and it will be our scale. Because in this case, it will be 1 by 3, 3 by 1, 1 by 1. It's widely used in mechanics, in circuits, in economics, everywhere. Actually, just one operation which helps you to. It small looks like even like I told you, system of linear equations, rather than just something magical. So let's go to the first task. If you already solved it at home, then solve this way. Multiply these two matrices. If you did this at home. If not, do it now.
Is it -1 in second matrix?
-1, 1, 2.
1.
It looks boring, yes, but actually you need to learn how to do that. So otherwise, you will receive D grade because you make some silly mistakes in your quizzes or midterms, and it won't be so nice. Okay. Who can remind me the numbers?
1, 2, 3.
First
First column 1 to 3.
Second.
Second -1, 0, 1.
Okay.
And we need to multiply it.
Yes. Who wants to do it on the whiteboard?
Okay.
Давай ты. Нет. Otherwise, Lyoха will kill me if you won't know all matrices and so on. Multiply? Yes.
-1 это margin. Okay, just second row, first column. What is it? Why is 9? Just 10 plus 0 multiplied by -1.
Ah.
Yeah. That's it.
So you already just decrease the grade because you made some silly mistake. I just showed that it's the reason why you need to get how to calculate it correctly. It's the reason why you need practice. That's it. What about those tasks? Actually, I don't see any reason to check it because you can check it by yourself using Python and whatever. Or even you can write решение matrix online, and that's it. You will find some online solvers in web. So far so good. Next task. I will show how to think there. Actually, it's widely used on this notation, widely used in robotics, and I will explain also another notation. So, for instance, we have A, B, C. We write A, B, C. So, see, actually, I made a lot of mistakes there, so I don't know why I had the same 2 times. K should be 1 by 3. I will change it later, but for now, know that K is 1 by 3. Okay, so 3 by 3. After this, we have 2 by 3, and C is 3 by 2. You should go everyone from left to right, and you just, this should be the same. In this case, you may see something the same, so no solution. Put transpose, then it will be 3 by 2, and also their transpose, yes? 2 by 3. Okay, bit mess. 3 by 3, 3 by 2, and 2 by 3. So, solution 3, array. Okay. Zahar, solve the other 2 tasks in the whiteboard.
Okay. On the blackboard?
Yes. Actually, it's whiteboard.
Oh, yeah.
Other do it if you didn't do it at home. You buy it.
So E is 1 by 2, B is 2 by 3, A is 3 by 3, and E is 1 by 2. So again, there would be
You try to do it overkill, just to watch on the numbers, like I wrote it. I mean,
okay.
2, 2, near. Okay, you can guess. 3, 3, near. 3, 1, not
No.
work. Yes, so not exist. You don't need to think, you just need to watch and do like this.
Yeah, okay. So,
And the last one. Go here, we need to show it on the camera, the solution. Okay, you can continue. So, okay, yes. As I told you, write it 3 by 1 because I mean 3 by 1.
Yeah. I write transpose.
I told you that I made a mistake. Right now it's 3 by 1, 2 by 1.
Ah, okay.
Actually, the solution will be the same, but in another place.
Actually, we can do with this.
What is it? Does it mean cross?
Cross products.
And can we find the cross product between two K's?
Yeah.
And what will be?
And it will be so. It will be 3 by 1.
Yes.
So. And so
We want to see yes. The question, the major. Well, first asked me from previous group that, but what about order? I can say that, as you remember, we can rewrite dot product as, say, A transpose and I mean transpose B. In this case, you don't need to think; you just need to go from left to right. In this case, what we can do? In this case, you can think, it should be the first or second or whatever. You can just rewrite in skew-symmetric matrix, as you remember, to be 3 by 3 multiply 3 by 1. And the solution will be 3 by 1. So if you don't know about, did you get what about skew-symmetric matrix we covered in the previous class? Or you forget about it? It seems so, yes. Then, how can you find the cross product? In classical way, EAGLA1 and you do something. Or you can write a matrix, skew-symmetric with zeros, and there are some x, y, z, of course somewhere some minus there probably.
minus x.
No, minus x or like this. Actually, did you remember this matrix?
Yes.
So it's 3 by 3. You can rewrite this one to k transpose hat, k transpose c, e transpose. In this case, you don't need to think about other stuff. You just know that it will be 3 by 3, 3 by 1, 2 by 3, and 2 by 1. And yes, because of this one, the solution doesn't exist. Are you with me? Did you get it?
Yeah.
Понял? What you didn't get?
You said that, question was about order and why we multiply firstly these 3 matrices and then we multiply the first one.
You always go from the left, right. You need to multiply this one, after there's a solution to this one, and so on. So, boom, boom, boom. You always go from left to right.
In third or fourth one.
In fourth one, I told you, cross product, you may ask the question, does it have any other order? Because some students from previous group asked me this. My answer is, if you don't remember the order, actually it doesn't matter. You know the order of common multiplication. It's just from left to right. You know it? Probably yes. So you can rewrite this one to the knowledge that you know. Sometimes you don't know some forms, but if you know how to transform into one form to the form that you know, it's the best solution. In this case, you just can write it in common multiplication like I did there, using two-symmetric matrix. You don't need to use, or whatever. I put, for instance, A dot B dot C. Is this okay? Okay, not, or whatever, like this. I just like this. Because in this case, okay, what there should be the first order, the second order, and so on. I don't know. Okay, but what can I do? Okay, I know this guy, we have brackets, it should be first, because brackets everywhere like this. What will I do? Do the B hat C, A. Actually, even now, we can omit this bracket, because it will be, I mean, no, we cannot get it. 3 by 1, it will be 3 by 3, C, it will be 3 by 1, boom, and we cannot do it because we need to put transpose there. We can transfer this, I mean, like this, sorry. Okay, I'll rewrite it again. We can rewrite dot product as S transpose B cross product C. We can rewrite this one in A transpose B hat C. Now, what we have? So, after this we can just write, we can put brackets, despite it, you will receive the right solution. Because it will be A transpose is 1 by 3, this one 3 by 3, this one 3 by 1. What you didn't get?
Now we get that first we multiply them not as matrices but as vectors.
Vector is the same as a matrix, actually.
Yes, but
vector has some geometrical representation, actually matrix too, but
if there are more than 2 rows or 2 columns, then it's matrix. Because matrix consists of many vectors.
According to the definition of matrix, n by m, and nobody said me that n by m cannot be n equal to 1, m equal to 1. So actually scalar also can be represented as matrix. Or vector is also a matrix, according to definition.
Yes, but not all matrices is vectors.
Vectors is just free. It's when you have one column. That's it. But also you have the geometrical representation. Okay. The last one. I am waiting for answers. First of all, you need to get is it exists or no, otherwise you don't need to Google it if it's so. Does A exist?
Yeah. Yes.
Why?
Just because A is matrix 1 by 3 and B is matrix 1 by 3. 3 by 1. Sorry. And we get 1 by 1 matrix.
Okay, what about the second part of A?
B and A?
Yes.
It exists also. 3 by 1 and 1 by 3.
So it's called outer product. I showed it today. Or it's called one rank matrix. What is it? It's better to open Wikipedia and read about it. Actually, it's not quite useful, but you may know about it, at least about how the application about it. I don't want to spend time on it because it's not so useful for you. But if you want, you are welcome. What about B? Because in this case we can see it. I mean, this way. It won't and so on. Okay. About multiplication, I hope you can multiply AB just go 1 by 1 dot product. When one rank product in this case, it's a bit awkward because you just need to multiply only one column, one arrow. It looks not so nice, and sometimes you can make a mistake just because you used to do another way. Used to do like this. In this case, you will just boom, 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 boom. So I win. So I will show it. Ну, короче, я сделал зачем-то transpose by transpose. Okay, so in this case you need to, it will be 2 minus 2, 1, after this you go another, it will be, so minus 2, 2, 6, and so on, 3 by 3 matrix. Just be aware that in outer product you don't have any, summation, only multiplication of one number. Okay. I asked you about this meme about potato English. You told me that you don't know it. So there is on the screen. So now you started to learn some ancient memology, you know? It is not so popular now, but when I was young and innocent, it was popular. Now the next topic is determinant. So, first of all, I'd like to really recommend you to watch the video from this guy, Friedel Brown. Actually, it really helped me a lot when I was a first time TA. I will put some video there because he explained really nice, use a lot of illustrations and so on. So I really recommend you to watch this video after each class when you have a new topic. Now let's watch about the determinant.
Hello again. So moving forward, I'll be assuming that you have a visual understanding of linear transformations and how they're represented with matrices, the way that I've been talking about in the last few videos. If you think about a couple of these linear transformations, you might notice how some of them seem to stretch space out, while others squish it on in. One thing that turns out to be pretty useful for understanding one of these transformations is to measure exactly how much it stretches or squishes things. More specifically, to measure the factor by which the area of a given region increases or decreases. For example, look at the matrix with columns 3, 0, and 0, 2. It scales I hat by a factor of 3 and scales j hat by a factor of 2. Now, if we focus our attention on the 1 by 1 square whose bottom sits on I hat and whose left side sits on j hat, after the transformation, this turns into a 2 by 3 rectangle. Since this region started out with area 1 and ended up with area 6, we can say the linear transformation has scaled its area by a factor of 6. Compare that to a shear, whose matrix has columns 1, 0 and 1, 1, meaning I hat stays in place and j hat moves over to 1, 1. That same unit square determined by I hat and j hat gets slanted and turned into a parallelogram, but the area of that parallelogram is still 1, since its base and height each continue to have length 1. So even though this transformation smushes things about, it seems to leave areas unchanged, at least in the case of that one unit square. Actually though, if you know how much the area of that one single unit square changes, it can tell you how the area of any possible region in space changes. For starters, notice that whatever happens to one square in the grid has to happen to any other square in the grid, no matter the size. This follows from the fact that grid lines remain parallel and evenly spaced. Then, any shape that's not a grid square can be approximated by grid squares pretty well, with arbitrarily good approximations if you use small enough grid squares. So, since the areas of all those tiny grid squares are being scaled by some single amount, the area of the blob as a whole will also be scaled by that same single amount. This very special scaling factor, the factor by which a linear transformation changes any area, is called the determinant of that transformation. I'll show how to compute the determinant of a transformation using its matrix later on in this video, but understanding what it represents is, trust me, much more important than the computation. For example, The determinant of a transformation would be 3 if that transformation increases the area of a region by a factor of 3. The determinant of a transformation would be 1/2 if it squishes down all areas by a factor of 1/2. And the determinant of a 2D transformation is 0 if it squishes all of space onto a line, or even onto a single point, since then the area of any region would become 0. That last example will prove to be pretty important. It means that checking if the determinant of a given matrix is 0 will give a way of computing whether or not the transformation associated with that matrix squishes everything into a smaller dimension. You'll see in the next few videos why this is even a useful thing to think about, but for now I just want to lay down all of the visual intuition, which in and of itself is a beautiful thing to think about. Okay, I need to confess that what I've said so far is not quite right. The full concept of the determinant allows for negative values. But what would the idea of scaling an area by a negative amount even mean? This has to do with the idea of orientation. For example, notice how this transformation gives the sensation of flipping space over. If you were thinking of 2D space as a sheet of paper, a transformation like that one seems to turn over that sheet onto the other side. Any transformations that do this are said to invert the orientation of space. Another way to think about it is in terms of I hat and J hat. Notice that in their starting positions, J hat is to the left of I hat. If, after a transformation, J hat is now on the right of I hat, the orientation of space has been inverted. Whenever this happens, whenever the orientation of space is inverted, the determinant will be negative. The absolute value of the determinant, though, still tells you the factor by which areas have been scaled. For example, the matrix with columns 1, 1, and 2, -1 encodes a transformation that has determinant, I'll just tell you, -3. And what this means is that space gets flipped over and areas are scaled by a factor of 3. So why would this idea of a negative area scaling factor be a natural way to describe orientation flipping? Think about the series of transformations you get by slowly letting I hat get closer and closer to J hat. As I hat gets closer, all of the areas in space are getting squished more and more, meaning the determinant approaches 0. Once I hat lines up perfectly with J hat, the determinant is 0. Then, if I hat continues the way that it was going, doesn't it kind of feel natural for the determinant to keep decreasing into the negative numbers? So that's the understanding of determinants in 2 dimensions. What do you think it should mean for 3 dimensions? It also tells you how much a transformation scales things, but this time, it tells you how much volumes get scaled. Just as in 2 dimensions, where this is easiest to think about by focusing on one particular square with an area 1 and watching only what happens to it, in 3 dimensions, it helps to focus your attention on the specific 1 by 1 by 1 cube whose edges are resting on the basis vectors, I hat, J hat, and K hat. After the transformation, that cube might get warped into some kind of slanty cube. This shape, by the way, has the best name ever, parallelepiped, a name that's made even more delightful when your professor has a nice thick Russian accent. Since this cube starts out with a volume of 1, and the determinant gives the factor by which any volume is scaled, you can think of the determinant simply as being the volume of that parallelepiped that the cube turns.
So now let's try to write down the table or the core ideas from this video. So, what did you get from this video?
Determinant is the area or volume of some figure.
Okay, the determinant is area or volume. What else?
It is scalar.
Okay. What else?
Just compare with matrix that with basis that have unit vectors.
So it's about, yes. Okay, it's how can you write down it? I mean, rephrase it.
When we get determinant, we get the number that represent how much scales our area when we choose not as a basis of unit vectors, but basis of these matrices.
Actually, Scalar factor, yes, but actually the problem is that we will cover transformations, affine transformation to be precise, later during the course. So for now, just to take in your brain, but we will cover it later. I mean, totally. But yes, scalar factor. What else?
If determinants is less than 0, coordinates must be reversed.
Now you say it not generally, you just say that if else. It has sign. The sign depends on the, yes, orientation. So we can say that it's present not only the area but also the orientation of our guy.
Yeah.
About orientation. So, okay, the first question. What is the difference between this one and scalar triple product?
Scalar triple product is absolute value. I mean, only positive.
Other suggestions?
It's only for 3D.
Actually, no. Yes, only 3D, it doesn't matter. Actually, it's the same. Scalar triple product and determinant is the same, and you can find it the same. And you're wrong because, as you remember, that how can you find a scalar triple product? You write determinant between these two 3 by 3 matrix, so it's the same. It was tricky question to check that. Okay, what did we forget there?
Right. Actually, we can have matrices in more than 3-dimensional spaces, and it represent some number in 3D space. It represent value in 2D space. It represent play at an area, and in higher dimensional space it will represent something that we can get by multiplying all vectors.
Okay, what about so can we find determinant for non-square?
No.
Yes, it's correct. We cannot find. So determinant can be found only for square matrix. Yes, and by end. What's the, let's say, how the determinant and the cross product relates to each other?
Determinant and cross product is for 3-dimensional space. The same.
And I have in cross product I receive a vector. In determinant I receive a scalar. It doesn't look the same.
Norm of this vector is determinant.
Let's check it because some of you I see didn't get what I talked about. Could you find me? So we have 2, 0, and 3. So it's 2. So you need to find the cross product of this guy and after this length, and you need to find the determinant for this guy. So cross plus length, and for this guy determinant. Actually, I help you. I put 0 there because you cannot find cross product in 2D. And check the result. Who wants to do it in the whiteboard? Nasty. Go. Could you write in column form? Now you need to find the length. You didn't find the length. And yes, it goes to, so you may say the same. Actually, as I'm not mistaken, cross product can be derived with the determinant. Because if I talk about derivation, I mean, how to get the cross product. So, why do we need it? We need to find inverse matrix, find matrix rank, find possible solutions, and solve using current parameters rule. Do you want to know what the equation between inverse matrix now, or we can cover the next class because it will be a topic for the next class? But I can explain it now. Why do we need inverse matrix in general?
Yeah, we can.
Okay.
Please explain it.
Okay, who wants else? Okay. So actually, even not. First of all, you need to know that the classical way you can find inverse matrix in ideal case only for square matrix. So you cannot find the inverse matrix for instance 3 by 1 or 3 by 2. But if we are just doing straightforward, we can using SVD or least square solution, we can find the pseudo-inverse matrix. We can find pseudo-inverse matrix for everyone, for every matrix. Of course, for now we won't cover it. Even more, if not mistaken, it will be covered during this semester. It will be on the next semester on linear algebra 2. But just to know that in pure, I mean straightforward, you cannot do it. But if you know some advanced technique, you can do it. Okay, but actually you won't need it during this semester. Why do we need it? Actually, because as I told you before, we will meet it when we will start to change the basis part. So we have, for instance, A1, A2, A3, it's a basis. It's new basis. We have all bases. And of course, to transform from one to another, we need to put A. It's transformation matrix 3 by 3. So we want to find this A. How can we do it? We cannot just divide this one. Why? Because according to the definition of matrices, we cannot use division. But we know one property. C is just matrix. It's C minus 1 C equal to identity matrix. Identity matrix, I hope you remember that it's 1, 1, 1 diagonal. And as you remember, the order also important. So, for instance, I want to find A. What do I need to do? I need to put either there or there. In this case, we need to put there. That I1, I2, I3 minus 1. How to find it, we will cover next class. For now, we don't need it. Hooray, we can find A. Okay, let's try to find this one. For instance, we know transformation matrix in this one. What we can do? We need to put minus 1 there. So it will be, we want to find this one, we need to drop A. What it will be? A1, A2, A3, A minus 1 equal to A1, A2, A3, A minus 1. It does. I forgot to put that actually the same. It will be identity. And yes, we can find this one. Now you may ask how do I need to think? Actually, it works the same as you did it in common equation. So for instance, 3x plus 2y equal 3, for instance. We used to do like this. Yes? What does it mean actually? It means that we multiply this guy on 3 and this guy on 3. So the same situation there. We can say, okay, so for instance there, a minus 1. And we just put it and solve.
How you multiply them? From left side or from right side?
Of course, from you always have multiplication left matrix and right matrix every time. So from left to right, you can just you can put this so either on the right part or on the left part. And there, you actually in math you also can write like this, but it doesn't matter in let's say it doesn't matter in not matrices. When we work with scalars, it doesn't matter when we can put our multiplication or subtraction or whatever. In matrices, it's important. Kramer's rule actually is useless stuff, but it's in your home task because you just need to open wiki and solve this task. Why do you need it? Just to get that it's useless and very inefficient way to find system of linear equations. I don't want to spend time on this. Am I right that it's useless? It's not very useful, but actually, it's in terms of programming, it's quite inefficient. In terms of everything, it's quite inefficient, but it exists. So you just need to know that if you have more tools, it's better for you. The reason. Okay, let's go further. No, okay. How to find determinant? Probably you already know because we found cross product using the same approach. But I'd like to ask you the question. We used to take this A1, A2, yes, this one. Can we take other numbers? For instance, can we take these numbers?
Yes.
Okay. So now, also there are some sectish approach like this one. Actually, you just need to put these two columns and put it there, and after this, draw this way. So in this case, A11, A22, A33 there. We'll summarize with this plus this minus the upper points. But actually, I don't recommend you to use this because actually, it's for me, it's much easier to use the common one. But if you want, it's up to you. I just give you a possibility. About scalar triple product. Actually, yes, it's a geometrical representation of our determinant in this case. It's signed volume. You can write like this. You find determinant and blah blah blah. Okay. What is the solution? You have 5 seconds. No answer? What I'd like to show, because it's really, I can ask you and I can answer in 5 seconds, even though know the answer. What do I need to do?
Just 0?
Yes. Why?
Because.
You calculated it?
Yes, exactly.
Okay. It's dummy approach. Smart approach to watch on the matrix first and see. How I give you a hint. You see 0 and have minus 1, 1. It's better just to check if I summarize these two guys, will be 0. Okay, let's check. I spent 5 seconds. Minus 2. Okay, it's linear dependent. It means the determinant equal to 0. And I don't need to spend my time on it. So, smart guy, first of all, need to check. Sometimes you don't need to solve something. You just need to say, okay, 0, I don't need to spend my time on it. But you think like, okay, my professor told me, okay, I need to solve this dumb equation. If I put this one, I don't know, 5 by 5 and send you on the midterm, guys, you have 30 minutes, solve it. Actually, I did it with Graham Schmidt in the previous semester, and only 2 people get that. First of all, you just need to check, is it linear dependent or no? One of them checked it. Okay, it's the same, you don't need to do anything. Otherwise, others spend a lot of time, makes dozens of mistakes of calculations because they cannot use calculators and so on, and fail. One guy just solved it in I gave this task as a quiz. 2 minutes later, Oleg, I solved it. Don't say anything anyone how to do it. Goodbye. That's it. So try to think. I know that's difficult even in Nopolis. Not even because you're in Nopolis.
It doesn't matter if rows or columns are linear dependent. Yes, in both cases, terminal will be 0. Yes.
You can check. Really, check it. So it's your home task. Check. Can be a no. The guys, you're laughing, but actually he is a nice person because he asked the question, why I didn't provide you a solution now? Because you have all tools to find the solution. Am I right? You know how to multiply matrices, you know how to summarize and subtract them. So you can check. When you check by your own, in this case, you will know the material because you did it by your own. Your brain works like this, that if you do something, you will learn it better than I just say you the answer. So you can check. As I told you before, when my way of learning something, you took some task, for instance, okay, this one. I know the answer, determinant should be equal to 0. So I have the solution even. But okay, let's try think another way. Okay, if I change this 0 to 1, for instance, what's happened? And I try to do it. Of course, I can use computer to check my result because it's just computational one. Okay, if I change, okay, let's put 0 there. I see, I cannot multiply non-square matrix because it doesn't work in this case. I mean, if you put it, you will see that it won't work. Okay, so I need to have square matrix. Yes, you will spend 1-2 hours to check all your hypotheses. But in the end, you will get you will get how to work with it, and you can easily solve it. If you just want to have the answer, you won't get how to work with it, and you will just do ad hoc solution. I mean, just it's like a hash matrix and a hash table, for instance. I don't know that you have A, you know B, but if you try to play with it, you know how to work with it, and you can. Actually, I will explain in the next next class how to prepare to exams, and also I will cover one interesting topic for you to get how to learn something new. Some properties, actually we don't need it today, but sometimes it may help you. Just open slides, check it, all the slides. This task, but I'd like that, for instance, some of you, for instance you, because you look boring, yes, go to the whiteboard. Go. I want that you need to use this column as a determinant when we have this equation. So you should have something -3. I wrote it incorrectly. 7, 2. So your answer should be like this. You told me that you can use any numbers, so prove it that it is like this. So find determinant, but not taking the first row, but using the second column. Because you told me that, yeah, we get it, we can, so let's prove it then. I recommend you to firstly to write down the equations there. I mean the full matrix, write it, because I want to change the slide. Не вижу легких потенищ. How to find the determinant for 2x2 matrix? If you did it on your sheet using one approach, solve it using other approaches to check that the answer will be the same. Because, for instance, you don't know how to solve this one, but you know how to solve using first row. So you can have a, let's call it ground truth. So you have one which you already know that it will be the correct, and you're using other approaches. I mentioned it before. You have the answer and you can check it using other approaches. Who will solve it except Nest? What the answer? What?
It's the same answer.
What the same answer? Somebody didn't get. -1. Okay. What the problem there? The problem is that you don't know the formula. Because you used to do like monkey instead of to know the formula on the screen. So -1. So we have, for instance, this one. Actually, you need to multiply -1, 1 plus 2, 3. So it should be plus. The second one, 2 by 2. Should be plus, yes, it's correct. The last one, 1 plus 3, 4. Correct. Did you get? No? What you didn't get? So see the formula. In original one, A11. Why do we have minus there? It's the answer. Because some of you ask me, why do we have minus? Because according to the general equation, it will be, what it will be? 3, like there. So we should have other sign. Is the reason why we have minus. There we have 2, and there we have 1, 2, 3, 4. Is the reason why we don't have minus. That's the case. Who didn't get? Did you get? No. What you didn't get? Try to formulate.
It's hard to solve in this way.
You need to know that you can do it. I show you the tool because you do it like monkey. You know that you need to go the first row, that's it. But actually I put the equation for you, especially that you can do it. For instance, on the midterm they ask you, solve it using, I don't know, take me these 3 numbers. You can do it. According to the equation, you can do it. But you, I didn't do it anytime. So, how can you do it? Just write down this equation. And you don't need to forget. So, actually, if I were you, I just write it like this. Let's take this. So, 1, after this, -1, 1, 1, 2. Great. Some guy. Okay. Plus -1. It will be 2, 2, 4. Some guy. Plus -1. 3, 3, 6. It will be -4. Bam, bam. How to choose the right numbers? You just need to, we have this one. We need to eliminate column and row, and it will be our matrix. 7, 2, 2 minus 4. It will be minus 28 plus 4 minus 24. Let's go further. Okay, 7. Of course I forgot to put 7 there. My bad.
Yeah.
Yes. Thanks. Okay, 7. You already found the solution, it will be there. -1, yes? Because we do like this, and 1 minus 1, 3 minus 4. And the last one, again, it will be 1 minus 3 minus 2, 7. 1 minus 3 minus 2, 7. So, so there is, it will be positive, -4, 7 minus 7. Так, мы где-то ошиблись. Не, мы ошиблись. Здесь написано. 24, 24, 10, 23, 21. 7, 7. Ну да, здесь плюс, а не минус. Окей. 7 plus 4, что там? 3, 2, так, минус 2, 7. It's a problem of math. Okay. So actually the algorithm is following. If you want, we can rewrite it again and try to solve, but I don't see that actually is a problem. I like this task. Now we have several minutes. Provide me several algorithms. Yes, the first one.
You can find dot product of vectors A and B.
How?
Dot product.
Dot product. Dot product. Okay. What? Okay, we found dot product. What else?
Divide by 2.
And
this is the real game.
Okay. One approach. Second approach. Yes.
We can find cosine and then find sine of the angle between A and B and use a formula A length of A multiplied by length of B multiplied by sine of the angle between them multiplied by 1/2.
Yes. So actually we can use cosine rule and sine rule for finding because we know two vectors and we can find angle between them. Yes.
Also we can Google it.
Okay, nice, perfect. Okay, I will show what we can Google from this. Yes.
We can find a cross product of these vectors, and we know that cross product is equal to area of the parallel parallelogram, and then multiply this area by 1/2.
Okay, nice. Other solutions, guys. Yes.
We can find length of the sides of the triangle. So we have 3 points, the region of coordinates, the end of the first vector, the end of the second vector, we can find the length between
Yeah, you
these
can
points
find, I
and
get it, yes.
use the formula of Geron.
We can.
Очень плохо там работает. Там корни страшно.
Okay, what else?
We can make matrix of these two vectors and original coordinates and define determinants.
Do you think it will work?
I don't think so, but maybe.
No, it won't work. Why? Because try to imagine. So you need to take someone, some other. If you want to say, okay, I put zeros, will it work? No. Why? Because determinant is, if linear dependent, it means that it will to zero. As you remember, all zeros is linear dependent to each vector.
Yeah.
Okay. If we took other, so in this case, you will have some, I don't know, some monster, which will be, I don't know, like look like this. I mean, it will be not, you cannot, it will be parallel pipette.
Yeah.
And it won't be like this, so you cannot just divide by 2 and hooray, I solve it. Other solutions, my friends. Okay, dot product, cross product. What else? Cosine and sine rule. Actually, dot product correlated to to it. Google it. Okay, I will prepare some extra solution to this. Try to think out of the box. We are spending time because you need to think. Any suggestions? What do you think? Okay. Do you remember how can we find the triangular? I will give you a hint. I want to find this triangular in 2D, as we did it before. In 2D, yes, it works. Now we're in 3D. But what do we need to do? What we can do with this?
Find first vector.
No, you don't need first vector.
Maybe just change base.
Perfect. Yes, we can change the basis. So now we work in Cartesian space. So we work in system coordinate, you know, and we receive these two vectors. So we need to change our basis that we will be on this one. How can we do it? I will show on fingers because it's topic for the next class. If you don't see, you can just stand up. Don't worry. Okay, I need to go somewhere. Okay, we have it like this. So it's our, imagine this our two vectors. Probably they not look like this because we have minus, but it doesn't matter. The idea. Of course, we can put vector in the zero. What do we need to do? We need to rotate. Actually, if we're using fancy words, we need to use Euler angles to find the solution of fixed angles. But for now, we just need to give intuition. First of all, if you're talking about pure translation, pure rotation, pure, I mean just rotate, we can solve this problem using free rotations. Actually, we can choose. I mean, we can change our vector in using only free rotations in any case. So they are called Euler angles. They look like. Okay, we'll show it later. So first of all, we need to rotate in one angle. How can we do it? We need to project it on the ground and find this angle. Okay. We rotate it. Next step, around this axis. Now, and it looks like this. We just need to again rotate around this to fix it somehow. Of course, it won't be on the same. So how it looks like on the ground? We want to receive in the end that we have A. I want to make it 1, 0, 0 in new basis. And B, I don't give a mess what it will be, but I want to have 0 there, and it will be 0. So actually in our case, we rotate firstly around Z axis, after this around Y axis, and after this around X axis. It's one of the possible representation of Euler angles. It's from robotics, probably shouldn't be explained you during the class, but I will explain it because it helps you to solve many tasks in much easier way than just you need to do it in common linear algebra. I don't see any probably reasons to, how to say, hide this knowledge from you. So, it's the last possible solution. In this case, we can just drop this 0 and we have 1 O x y, find determinant, divide by 2, and use all this easier math there. Yes, probably solution not so. The most elegant solution, yes, is cross product. Because cross product, in this case, you just find this area, I mean length of the, that's it. No problems at all. It's the best way, as for me. But as you may see, we found actually one extra solution is just the draw. Find GeoGebra, draw it in it, calculate. Yes, it's one of possible solutions. You need to solve the task. How you can do it, it's up to you. Yes, if you talking with guy from Ma, they told me you didn't prove that it's solution, blah blah blah. But if we're talking real applications, sometimes we just need to know the result. Try to think out of the box. I just provided that one small task, 1, 2, 3, I don't know, strings, okay, strings. And we can find the dozens of solutions. And the last task for today, so how can you find about, yes, internet? Yes, in Russian, because I didn't do it by myself, one friend helped me with it. So you find the area of the triangular, you may see a lot of fancy equations, Serabino, Cauchy. You can do it like this, of course, too. Actually, it works, they did it when you have coordinates, not vectors. In our case, we have vectors. But actually, it doesn't matter. So you can do like this, it's up to you. The last task. There are also several ways how to solve it. Let's discuss about algorithm. I'd like to ask you, so what can we do? What do we need to know for this, solving this task?
First of all, we should just express the determinant. And
No. First of all, I need to multiply a.
Yeah, multiply and express the determinant. There will be x in the equation, and there probably will be a quadratic equation.
Why do you think that's quadratic equation? Okay.
Parabola.
So, first of all, because you solved this task, as I see.
Yeah.
Some of you not. Okay, first of all, yes. A multiplied by b. What the dimension will be?
2 by 2.
So, 2 by 3, 3 by 2, 2 by 2. After this, why do we have quadratic equation? Because you may see that we have x from both sides, there and there. It won't eliminate, so it's the reason why we have. Okay, we have quadratic function. So how can we find the largest possible solution?
So we can just.
No, I'd like to. I get that, you know. I'd like to listen how others think. Inara, what do you think?
Okay, we just can analyze it as I solve this task, and we get the parabola just like this, and it has some vertex, and this vertex, it will be the largest possible value.
Yes, the first solution vertex is mean so parabola точка вот это. It's vertex in this case. Yes, you can find vertex, it will be the best solution. How you can check? Just yes, first of all, take this point, for instance, check the solution. Take this point, find the determinant, and take the vertex. Of course, you need to find it. Just open Google, or if you remember, it's nice. I don't remember how to find the vertex of the parabola, because if you have equation. And after this, you can check, okay, the best solution. Yes, others possible ways. Yes, use derivative. Yeah. You didn't learn it at school, and now, but some of you know it. What is it? By the way, what is it? Why can we use derivative there?
Derivative, we just derive our quadratic equation, and then we use to make it equal to 0, and then we find monotones of this function.
What the meaning of determinant? If you can use determinant, you need to know what is it. Otherwise, you just use, I don't know, you know what does it mean gun, and you put it on the person. What?
So we just this kind, yeah.
Speed?
Speed.
Okay, на спидах мы сегодня, I get it. Okay.
Velocity of increasing or decreasing function.
But I don't see any velocities there. Or speeds, I don't see any speeds or velocities there. I need to find the last possible value, not a speed. I don't know. Yes.
The tangent between the sine between.
Okay, it's tangent and okay, it's tangent. What else? How can it help us?
If the tangent is equal to 0, then it means that the function that this is a vertex of the function.
So, as I get it, most of you didn't get what does it mean, and you say, okay, let's use derivative. But if you don't know what is it, how can you use it? So it's a bad idea. For you, the vertex is the best way. When you learn how to derivatives during the class, okay, about, I'd like to show about derivative. How can you learn it? What is it? Just small hint. I draw the velocities profile. So, in robotics, it's called trapezoidal. So why do we need it? You start from the lowest velocity. After this, you try to reach the max velocity. After this, after this decrease to 0. For instance, I want to take this one, I move, and slowly down to this one. So, this velocity, we have x dot, or we can write like this, x2 dot, or we have, say, v s alpha a. So, the integral of this guy, it's площадь под графиком. We call it in Russian, yes. So, this one will be our solution there. So, integral, the integral of v will be s, and it will be площадь под графиком, or area among this figure. If we talk about acceleration, it's angle. It's how to say, if you're solving it numerically, x previous, divide by time. Actually, it will be exactly this angle. So this angle will be your acceleration. As for me, I get what I mean. If I need to explain this on the fingers, I try to explain like this. At least for me, it looks more understandable. Of course, we try to find for this point. Because we won't have our velocity won't change. It means that we won't have any angle. This point minus this point, it will be equal to 0, and we won't have any acceleration. But we will have our this. We'll have our path will increase. So yes, to sum up, we have two possible solutions there. Using the vertex or using determinant. About determinant, you will learn it during math analysis. In this case, you can operate it. Otherwise, I don't see any reasons if you didn't get what is it, the nature of it. So for today, that's all. Do you have any questions?